lesson 5-3, function rules, tables, and graphs. We have two vocabulary words today, which are incredibly important in this section. The first one is discrete data. Discrete data is data that involves a count of items, such as number of people or number of cards. For discrete data, indicate each data item with a point. Because we're talking about discrete things, things that you can count, you can't count half of things. You can't have half of a person. You can't have half of a hot dog, even though you could probably eat half of a hot dog. You can't sell half of a hot dog. So each item is one whole thing. You can't have parts of them. That's why each item is a point rather than a line. In continuous data, it is continuous. It means it continues to go on forever and ever. That is data where numbers between any two data points have meaning. For example, the measurement of temperature, 76 degrees and 76.2 degrees do have a meaning. Right? For example, if your body temperature is 98.6, you're fine. If it's 99.1, you're running a fever. That may not seem like a huge difference, but it does have high validity in the medical field. Length or weight can also have parts of things. You can weigh parts of a pound. You can be several inches taller than 5 feet. Okay, so you use a solid line to indicate any continuous data. We're going to learn today how to model both discrete and continuous data. Now you can model functions using rules, tables, and graphs. A function rule will show how the variables are related. A table will identify specific input and output values, and a graph gives a visual picture of the function. Let's say we are supposed to model the function rule y equals 1/3 x plus 2. This is a function rule, so we can look at it and see how the variables are related. We see that y is equal to 1/3 of whatever x is, and we're going to add 2 to that. If I want to model this, I already have the rule, so now I need to create an input and output table, and I need to create a graph. In order to create the graph, I have to create the table. When you create a table, you normally have an x value. You pick some values for x, you figure out what they would be based upon the function rule, and that determines what your values for y are. As a general rule, you normally plot 5 points, because 5 points guarantees that you are going in the right direction. You can see if you've misplotted a point or miscalculated a point very quickly because it won't lie in the same line. And normally, I use the numbers -2, -1, 0, 1, and 2 when I'm plugging in my values for x. This is a different type of function because if you look at it, you can see right here that x is multiplied by the fraction 1/3. Personally, I don't like dealing with fractions, so instead of using -2, -1, 0, 1, and 2, I'm going to use whole numbers in which when I multiply them by 1/3, the 3's will cancel out. In other words, I'm going to use multiples of 3. So I'm going to use -6, -3, 0, 3, and 6 as my input values for x. Now all I'm going to do is I'm going to plug through my function, which is right here. I'm going to multiply whatever I put down for x into this, calculate it out to figure out what my y value is. So I have 1/3 times x, which I said was -6. Remember, if I have fractions here, I can cross cancel. 3 goes over itself once, it goes into -6, -2 times. -2 times 1 is -2, plus 2, the 2 that comes from up here. I get -2 plus 2 is 0. I'll take 1/3, multiply that by -3 over 1. Again, I can cross cancels. These are both 1s. -1 times 1 is -1 plus 2 is +1. 1/3 times 0 is 0. Add 2 to that, I get 2. 1/3 times 3 over 1 is now 1, plus 2 is 3. And 1/3 times 6 over 1 is 2, plus 2 is 4. Now I'm going to graph these. Remember when you graph x first and y second. You go left and right first, up and down second. My coordinate point is right here, 6, 0. Okay, that's my first coordinate point that I'm going to graph. So I'll come over to my graph, start at my origin, where the x and y axis intersect. I should write x and y down here so that we know which ones are the axes. We're counting by 1s, so I don't need to label any other part of the graph. If you count by something other than 1s, you must label some other part of the graph. I'll start here at 0. I will go left 6 units and up 0 units. So there's my first point right there. My second point is at negative 3, 1, so I'll start the origin again, go left 3, up 1, there's my second point. My third point is 0, 2, so I'll go left and right none, up 2, there's my third point. My fourth point is 3, 3, so I'll go right 3, up 3, there's my fourth point. And my last point is 6, 4, so I'll go right 6, up 4, and there's my last point. The last thing I will do, take my ruler to create a straight line. You take your straight edge or ruler and do the same thing. Please use a ruler, don't freehand. And since I can't use a ruler on my smartboard, I will just use a regular line here, and I will connect all my points with a nice straight line. And I missed a little bit here, so I will fix this by bringing it where it belongs. There we go. And I will put arrowheads on my line so that we know that it continues forever in 2 directions. And last but not least, I will label my line. I have to label my graph. My label of my graph is the equation right here. So I will label this y equals 1/3 x plus 2. Please don't circle this and draw an arrow. Literally label your line. So we have our table of values, we have our graph, and we already had our function. Now, when you graph something for a real-world situation, you need to choose appropriate intervals for the units on your axes. Your intervals need to be equal, so don't count by 5s and then go to 10s and then go to 20s. Okay? If you're going to count by 5s, go counting by 5s all the way through. Also, if the data are positive numbers, you only need the first quadrant. For example, here's a problem. At the local video store, you can rent a video game for $3. It costs you $5 a month to operate your video game player. The total monthly cost, C of V, depends upon the number of video games V that you rent. Use the function rule C of V equals 5 plus 3V to make a table of values and graph. And remember, C of V is like saying Y, and the V is like saying X. So don't let those little things confuse you. So I could say here, my table, I'm going to have a table with V, and for my Y value, it's going to be C of V. And my function is still 5 plus 3V. Now, I want to figure out the total monthly cost. They are not paying me to play video games. Therefore, I cannot have a negative monthly cost. So I don't need to choose 2 negative numbers in this particular case. So I'm just going to choose 0, 1, 2, 3, 4, and 5. So I have enough points. Okay. If I read no video games at all, I have 5 plus 3 times 0. That's going to be 5 plus 0, which is 5. It will cost me $5 to play my video player. If I rent one movie, I'm going to have 5 plus 3 times 1, which is going to be 5 plus 3. It will cost me $8. If I rent 2 movies or 2 videos, 5 plus 3 times 2, which is going to equal 5 plus 6, which is 11. If I rent 3, 5 plus 3 times 3, which is 5 plus 9, which is 14. And we can probably just go stop at 4 here. 5 plus 3 times 4, which is 12. 5 plus 12 is 17. I could go all the way to 5 plus 5, but I'm not going to. In this particular case, I need to graph my data. Okay, I also need to label my axes. So this axis is going to be V, and this is going to be C of V. Okay, and it might even be helpful to say number of videos, number of games, actually no, that would be cost, wouldn't it? Yep, that would be my cost, silly me. Number of games goes on the x-axis. Number of games, and so is my cost. And it would be in class. Okay. I need to make sure I label. Okay. So I'm going to move this because it's in my way. I have a low of 5 and a high of 17. And I'm not going to say 5. I'm not going to label this as 5 and this is 8 and this is 11. You can't do that when you're graphing because I can't have 3 here, 3 here. I can't have weird intervals. So I'm just basically going to graph, okay, this is 0. And maybe I want to graph by 2s. Okay, 2, 4, 6, 8, and Lovely. Okay. On my other axis, I only need to go from 0 to 5. So I'm going to go 0. I'm going to skip every other line. There's 1, skip 1, that's 2, skip 1, that's 3, skip 1, that's 4, skip 1, that's... I don't have to, but it just looks nice and neat this way. And then I'm going to plot my points. 0. When I rent 0 video games, it cost me $5. So I'm going to put $5 on my graph, which is about right here. And when I rent 1 video game, it's $8, so 8 is right here. When I rent 2 games, it's $11. 2 would be 11, which would be about here. 3 games, it's $14. 3 and 14 is right here. And last but not least, 4 and 17. So 4 and 17 is right here. I am not going to connect this data with a line because I can't rent half a video game or a quarter of a video game. I either rent the game or I don't rent the game. Can't have part of the game. Doesn't work too well. So this would be discrete data, which means the numbers between the values between the points don't matter. So last thing I need to do is label the function. So I would have C of B equals 5 plus 3B, and I'm done. So that's the difference between discrete data and continuous data. Let's model a few more function rules just to get some extra practice. Let's say we have y equals 3x plus 4. Again, we need a table of values. So I'm going to have my lovely little table of values. 3x plus 4. There are no fractions, so I'm going to use -2, -1, 0, 1, and 2, because it makes it pretty simple, pretty easy. So I'm going to have 3 times -2, which is -6, plus 4, which is -2. If x is 1, I have 3 times -1, which is -3, plus 4, which is 1. If x is 0, 3 times 0, which is 0, plus 4, which is 4. If x is 1, 3 times 1, which is 3, plus 4, which is 7. And if x is 2, 3 times 2, which is 6, plus 4, which is 10. So there's my table of values, and my graph is right underneath here. So I'll squeeze that in. Again, label your x and y axis. And then I'm going to plot my points. Might remember your points again. X value, y value. This is my x value. This is my y value. So I'm going to plot the point -2, -2. So I will start here at my origin, go left 2 and down 2. There's my first point. Then -1, +1. -1, +1 is right there. 0, 4, 0, 1, 2, 3, 4 is right here. 1, 7, 1, 1, 2, 3, 4, 5, 6, 7 will be right about there. And I can't plot my next point because it's off the graph, which is fine. At least you have to have a minimum of 3 points to graph on your graph. You need to have a minimum of 5 points in your table. So if your table has more points that you can graph, that's okay. Again, you can look at this and see if you're right, because if one point ends up to be way out of line and you can't draw a straight line to it, you'll know you did something wrong. So I'm going to draw my graph here, which I'm off again. So I will fix that here. Just a little bit. Okay, that's very close. Off of just a tad, but not too bad. And of course, you should draw your arrows on it again. And you should label your graph, which is y equals 3x plus 4. If we look at our second problem over here, you will notice it has a fraction in it. So again, when I'm making my table of values, I'm going to make sure I don't use -2, -1, 0, 1, and 2, because those won't work out really well for me. I'll end up with fractions, and who likes to graph thirds? They're kind of hard to graph. So 1/3 x plus 2. So I will choose -6, -3, 0, 3, 6. Okay. This is the same graph we did just a little while ago, so if we look back 2 pages, okay, same graph, so I'm not going to continue to do this again because it's the exact same graph we did before. So we'll skip that graph and go to another problem. All right, let's look at this one. Determine whether the function models discrete or continuous data, then make a table and graph each function. At a ball game, they charge $2 for a hot dog. The function C of H equals 2H describes the cost H of hot dogs. Okay? Obviously, they can't sell half of a hot dog, so this would be discrete data. Okay? This is discrete data because you can't sell part of a hot dog. You can eat part of a hot dog, but they cannot sell part of a hot dog. Therefore, I only need one quadrant because everything's going to be positive. Therefore, I only need part of the x and y axis. So I'm just going to use the first quadrant. And I'm going to plot my data points and graph. Okay, so I have H and C of H. And this would be 2H in the middle. I'm going to use 0, 1, 2, 3, 4, and 5. Okay, 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. And 2 times 5 is 10. So there I have that. Now I can graph this on my lovely line here. So this would be the x-axis is H, the y-axis is C of H. This would be, I remember H is number of hot dogs. And my y-axis is the cost, which should be in dollars. When we look in dollars, huh? I need to go from 0 to 5 on my x-axis and from 0 to 10 on my y-axis. So here's 0, 1, 2, 3, 4, 5. Here I'm going to say 2, 4, 6, 8, 10. I still graphed by ones. I just labeled every other line instead of labeling every line. Just makes it easier. I'm going to graph in blue so it's a little bit easier to see. So I have 0.00, which is right here at the corner. I have 1, 2. 1 hot dog cost me $2. 2 hot dogs cost me $4. 3 hot dogs cost me $6. 4 hot dogs cost me $8. And 5 hot dogs cost me $10. Again, remember it's discrete data, so you do not graph with a line. Okay, we could title this graph Cost of Hot Dogs. And I should label it C of H equals to H. And I'm done. Okay, now let's take a look at some functions that are not straight lines. You can graph a function as long as you know its role. It doesn't have to be a straight line. After you've graphed the ordered pairs that you've calculated from the rule, join the points with a smooth line or a curve if they don't make a straight line. For example, let's graph y equals the absolute value of x plus 2. And I'm going to make my lovely table of values, so I'm going to have an x value and a y value. And I'm going to have the absolute value of x plus 2. So I'm going to use -2, -1, 0, 1, and 2. When they are not linear graphs, if they don't make lines, it's very, very important that you choose at least 5 points. You may need to choose more points so you can see what the shape of the graph is turning out to be. So I need the absolute value of -2, which is 2, plus 2, which is 4. The absolute value of -1, which is 1, plus 2, which is 3. Absolute value of 0, which is 0, plus 2, which is 2. Absolute value of 1, which is 1, plus 2, which is 3. Absolute value of 2, which is 2, plus 2, which is 4. Now, if I go to graph these points, you're going to notice something right away. You'll notice some of the points repeated themselves. So we have -2, positive 4, which is here. -1, positive 3, which is here. 0, positive 2, which is here. And then we have 1, 3, which is here. And we have 2, 4, which is here. I can't graph this with one single straight line, but this is an absolute value graph. And absolute value graphs always make little V's, just like this. So there's our little graph here of the absolute value. Pretty straight lines, not using a ruler, even though you should use a ruler. And of course, I'll label it. Y equals the absolute value of x plus 2. All absolute value graphs will be V's, V-shaped. Our next graph over here is f of x equals x squared plus 2. Again, it's not going to be a straight line graph. I know this because I've got a little square right here. And that square is going to indicate something and it's going to change my graph. So again, I will choose more points, x squared plus 2. Since there are no fractions, I can still use negative 2, negative 1, 0, 1, and 2. So I'm going to have negative 2 squared. Notice how that's put in parentheses. It's not the opposite of 2 squared. It's actually negative 2 squared, which happens to be 4, plus 2, which is 6. Negative 1 squared is 1 plus 2, which is 3. 0 squared is 0 plus 2, which is 2. 1 squared is 1 plus 2, which is 3. 2 squared is 4 plus 2, which is 6. Again, some numbers that are repeating, but you'll notice it won't be a V shape like the absolute value graph was. So I'll plot the points negative 2, 6, 3, 4, 5, which is right here, negative 1, 3, which is right here, 0, 2, which is right here, 1, 3, which is here, and 2, 6, which is here. Now we can't graph these with straight lines. It would be a really weird looking graph. But we can do what we call a smooth curve. You notice it's kind of curving up this way and curving up this way. This is called a parabola. It's the graph of a quadratic, which is anything taken to the second power. So this is y equals x squared plus 2. So not all graphs will be linear. Be aware of that and make sure you plot enough points so that you can see the shape of the graph so that you can draw the graph correctly. And that is the end of this lesson.